In this video, we're going to solve some math problems from our past paper, which is a 2016 paper 1, an internal past paper. And the first question is saying evaluate 8 to the power 2 over 3. That's the first question that we have. So before I attempt to that question, I want us to look at this. So we have uh, the square root of 4. So we have been told here to find the square root of 4, or rather, let me say, if you have the square root of 4 here, this can be written in this form as well. So 4 to the power half is actually the same as the square root of 4, because both this and this are going to give us the same answer. So now here, the question that we have been given in this form. So the best way for us to solve this question, we're going to write this form that we have been given into this form that we are more familiar with, so that we can evaluate this. So this 2 is actually for the root here. This 2 is actually for the root here. And if we have a root of, for example, let me keep 4 the way it is. The root of 4 here, we don't write a 2 if it is a square root. So we just write the root like this. We know that we're actually talking about the square root. And then this root of 4 is actually raised to a power 1, but we don't write raised to a power 1 here. We just write the way it is like this. So this one here is actually a power it is actually a power for this, and then this 2 here is simply saying it's for the root. So the denominator is the number that we have here for the root, and then the numerator is actually the power that this thing is raised to. So we go back to the question that we have been given now. We have 8 to the power 2 over 3. And then remember, we said the denominator is actually the number we have here at the root. So the denominator is actually the number that we're going to put here. So we have 3 here. So we have a 3 here. So this is telling us of the third root. And then we said that the numerator is actually the power that this thing is raised to. So it is raised to the power 2. So what is the cube root of 8? The cube root of 8 is actually what? Is actually 2. 2 is raised to the power 2. So 2 raised to the power 2 is actually what? Is actually 4. We have evaluated that question. Let us look at the next question. The next question is saying simplify 3 open brackets a plus 5 close minus a open a minus 2 close. So have 3 a plus 5 minus a minus 2. They want us to simplify this. They want us to write this in the simplest way possible. So the first thing that we have to do, we're going to expand this, and we should also expand this as well, and then we later on simplify. So 3 multiplied with a is going to give us a 3a. 3 times positive 5 is going to give us what? Positive 15 minus. So this minus is actually the sign that this a carries. So some students make a mistake of writing minus, and then they start multiplying this a alone with everything in the brackets this side. That is actually wrong. So you get this a with the sign. So this, we won't take it as a but we'll take it as a negative a. If you want to write a minus here, then you should open the brackets here. You have seen, then you should actually open the brackets here, and then you multiply this a with everything in the bracket, and then you later on multiply the negative with what you're going to have here in the bracket. So let me show you both ways. So if you write a negative here, you open the brackets. So a times a, that's actually a squared. a times negative 2, that's going to give you negative 2a. And then later on, we copy this the way it is, and then we multiply this negative with everything in the brackets. So we're going to have minus a squared and plus 2a. So this is what we're going to have. So if we took this as a negative a, we would have negative a times a is going to give us what? Negative a squared. Negative a times negative 2, it was going to give us what? Positive 2a, which is actually the same with this one. So if you take this as a negative, you write it as a negative and then you open the brackets. But if you take all this as a negative a, then you just go direct. So from here we're going to proceed. So we actually collect the like terms together. So here I have 3a and 2a. They're actually like terms. I can add 3a and 2a. It is going to give me what? It is going to give me 5a plus 15 minus a squared. Now if we look at this, this is actually a quadratic equation. This is actually a quadratic equation, so I can write it as negative a squared plus 5a plus 15, and this is actually our final answer. So we have simplified this one. The next question is actually saying the diagram below shows a right pyramid with a square base ABCD and an apex of P. And then the question is saying how many planes of symmetry does the pyramid have? So when it comes to planes of symmetry, we want to know in how many ways can we cut a shape that has been given, and then if we cut it, we're going to have the same shape. So for example, I have a rectangle. So how many ways can I cut the rectangle in such a way that if I cut it, the two shapes that I'm going to have, they are going to be of the same? So I can cut this rectangle here. Sorry, I haven't drawn it properly, but okay, I wanted to draw it at the middle, but since I'm using freehand, so that's why it went this side. So I can cut it at the middle here, and then this side and this side, I'm going to have the same shape. I can also cut it here, and I'll find that this side and this side, I'm going to have the same what? I'm going to have the same shape. Yeah, that's what they mean when they ask about planes of symmetry. So in this case now, we have what? We have a pyramid. We have a pyramid. So this pyramid that has been given, it is actually a square base pyramid. So this square base pyramid, how many times can we cut it, or in how many ways can we cut it, that if we cut it, we're going to have what? We're going to have the same shape after cutting it. The same shapes after cutting it. So that square base pyramid, we're going to focus at the what? At the base. So the base, they have said it is square. It is square. So we'll have a square base. So if we turn that pyramid and then we face the base, if we face the base, we find that we can cut the pyramid like this. That's one. We're going to have the same shapes. If we cut it also in this way, we're going to have the same shapes. And then if we also cut it in the diagonal, we're going to have the same shape. Even in this diagonal, we're going to have the same shape. So how many planes of symmetry does a square base pyramid have? So the square base pyramid have how many? 1, 2, 3, 4 planes of symmetry.